Okay, if you're going to solve this problem with the way we've been doing it so far, you get the LCD for the problem. What's the LCD? Well, I got to factor this denominator, so I want to point out I've done it over here. I'll just put these down for you: 1, 3, 3, 5, 5, 7, 7, 9, 9, 11, 11, 13. It's a nightmare. So I'll write this down. What it's going to be? It would be 3, 5, 7, 9, 11, 13. And it's really got an unusual number that we wouldn't be expecting to see. So I'm not saying it's wrong to do that, but it just seems like it's too much work to do that. So what I want to do is cross that off, not do that. All right. So what I want to do is just go back and talk about some things I would do in the problem. First thing I would do is you might recognize, you may not recognize it, but you've certainly done a lot of fractions before, and you should recognize that this is that these are equivalent. All right. What do I mean by that? If you combine these together, that would be x times x plus 2. And what do you get on top? You'd get x plus 2 minus x, which would be 2 over x plus 2. Well, after looking for the LCD, I kind of see these things. And what I mean by that, they differ by 2. 1 and 3 differ by 2, 3 and 5 differ by 2, 5 and 7 differ by 2, yada, yada, yada. They all differ by 2. So I wanted to get it to look like this. And the way I did that was I factored an a out, and I factored out a 2 in the denominator, so I'd get these terms over here now. All right? And then what do? I use this over here to split the term. All right, I'm going to split the terms. So let me write that down for you. So 2 over 1 times 3, again, we're using this. Well, that would be 1 over 1 minus 1 over, well, let's see, it would be 1 plus 2, which is 3. All right? That makes sense. So I can write these down. So I want to point out what I'm doing over here. This term here, let me get my eraser out. Oops, that's not an eraser. This term here is split into 2 terms. Let's go to the next one. This term here is split into these 2 terms. Let's go to the next one. This term here is split into these 2 terms. Let's go to the next one. This term over here is split into these 2 terms over here. Let's go to the next one. Well, I'm running out of colors, aren't I? Let's take a look. Let's go back to blue then. This term here is split into these 2 terms. And let's take another little color here. Just same, kind of you were using this one over here. Now, what do I notice about it? I notice there's a lot of cancellations over here. So this cancels, this cancels, this cancels. This is what's known as a telescoping series, by the way. This cancels, and this cancels. What are you left off with? Well, certainly a over 2, but on the inside of the parentheses, you're left off with 1 over 1 minus 1/13, which is relatively simple to do, by the way. All right? The problem's become substantially easier for me. So let me write this down. So 1 over 1 minus 1/13, common that would be 13 over there. You would get 13 minus 1, which is 12/13. Let me show where that is, right over here. The next thing I did is I reduced it. 2 goes into 12 6 times, so I get 6/13. Next thing I did, I'll write this down for you. I got a times 6/13 equals 12. I multiply both sides by 13 over 6. And what do you get here? Well, the 6's cancel, 13 cancels. You're left off with a. 6 goes into 12 2 times, and 2 times 13 is 26. Again, this is a bit tricky. But again, it's not beyond your skill set, all right? But again, a lot of students would approach the problem incorrectly. Certainly, even if they knew about the pattern, they still may approach it incorrectly. But the answer for this particular problem is 26. Thank you.